Today, we're embarking on a journey to a planet that has long been shrouded in mystery and intrigue: Venus. Often called Earth's evil twin, Venus is a world that seems eerily similar to our own in size and structure, but has taken a drastically different path. Recently, new discoveries have sparked a fresh wave of interest in this enigmatic planet, particularly involving its atmosphere and what it might reveal about Venus's past and potentially its habitability. Venus is the second planet from the Sun and is almost identical to Earth in size and mass, which is why it has often been considered Earth's twin. However, that's where the similarities end. Venus is a hostile environment, with surface temperatures reaching up to 460 degrees Celsius, 860 degrees Fahrenheit, and atmospheric pressures 92 times that of Earth. The planet is wrapped in a thick blanket of clouds composed of sulfuric acid, and its surface is a volcanic landscape with vast plains and towering mountains. No human or robotic lander has survived on Venus's surface for more than a few hours, making it one of the most challenging places in our solar system to explore. Yet, despite its inhospitable environment, recent studies have revealed some astonishing details about Venus's atmosphere that could change our understanding of its history. The European Space Agency's Venus Express mission, which orbited Venus from 2006 to 2014, provided detailed measurements of the planet's atmosphere. One of the most striking findings was the discovery of a dramatic increase in the ratio of deuterium to hydrogen. So what is deuterium, and why is this ratio important? Deuterium is a heavier isotope of hydrogen, containing one proton and one neutron in its nucleus, whereas regular hydrogen has only a proton. On Earth, the ratio of deuterium to hydrogen in water is relatively stable and serves as a fingerprint of our planet's water history. Scientists have found that Venus's atmosphere contains a deuterium to hydrogen ratio that is 120 times greater than that of Earth. This discovery suggests that Venus once had much more water than it does now, potentially vast oceans, similar to those on early Earth. But what happened to Venus's water? The leading theory is that over billions of years, Venus underwent a catastrophic greenhouse effect. As the sun's energy output gradually increased, any water on Venus's surface would have evaporated. High in the atmosphere, solar ultraviolet radiation would then break these water molecules into hydrogen and oxygen. Hydrogen, being the lightest element, could easily escape into space, while the heavier oxygen likely reacted with surface minerals or was also lost to space. Deuterium, being heavier than ordinary hydrogen, escaped less readily, leading to an enrichment in Venus's atmosphere. This gradual loss of water and enrichment of deuterium has provided a critical clue in understanding Venus's climatic history. These findings suggest a planet that might have been more Earth-like in its early history. If Venus had substantial amounts of water, what else could it have had? Perhaps a stable climate, a dynamic atmosphere, or even conditions suitable for some form of life. This brings us to an even more tantalizing question. Was Venus once habitable? Scientists have long speculated about the possibility that Venus could have supported life in its ancient past. Billions of years ago, when the sun was dimmer and less powerful, Venus might have had a stable climate with liquid water on its surface. Studies of ancient Venus suggest that if the planet had tectonic activity similar to Earth's, it could have recycled carbon dioxide through volcanic eruptions and subduction, helping to regulate the temperature. This period of potential habitability might have lasted for up to 2 billion years, giving any hypothetical life forms ample time to develop. However, as the sun grew hotter, Venus's atmosphere thickened with carbon dioxide, trapping more heat and creating a runaway greenhouse effect that boiled away any oceans and left the planet dry and barren. The clues about Venus's past don't just end with water loss. Recent research has also pointed to the possibility of volcanic activity on Venus being much more recent than previously thought. Observations from the Magellan spacecraft in the 1990s and more recent data suggest that Venus's surface could have been shaped by volcanic activity as recently as a few million years ago. Some scientists even hypothesize that Venus might still have active volcanoes. These findings are crucial because volcanic activity can release water vapor and other gases into the atmosphere, potentially creating a temporary, more hospitable environment. Understanding whether Venus is still volcanically active could help scientists piece together its atmospheric evolution and assess the potential for past habitability. But let's not forget the most intriguing aspect of the recent findings: the mysterious behavior of sulfuric acid aerosols in Venus's atmosphere. These aerosols are primarily found in the thick clouds that blanket the planet and are composed of sulfuric acid mixed with water. Recent studies suggest these aerosols could play a crucial role in the observed deuterium enrichment. As sulfuric acid droplets rise through the atmosphere, they can collect water molecules, including deuterium-enriched ones. At higher altitudes, the droplets evaporate, releasing the water molecules back into the atmosphere. This process could help explain the observed increase in the deuterium-to-hydrogen ratio with altitude, adding another layer of complexity to Venus's atmospheric dynamics. Understanding these processes is not just about studying Venus for the sake of knowledge. There are direct implications for our understanding of Earth and the broader search for life in the universe. By studying Venus, we can learn more about how a planet's atmosphere and climate can change dramatically over time. This knowledge could help us understand how Earth's climate might evolve in the future and inform the search for habitable planets around other stars. The new findings about Venus's atmosphere have also sparked interest in sending new missions to the planet. NASA and other space agencies are planning missions that could provide more detailed observations of Venus's surface and atmosphere. The proposed Veritas, Venus emissivity, radio science, INSAR, topography, and target for exploration. Its extreme surface conditions make landing missions incredibly difficult. The Soviet Union's Venera missions in the 1970s and 1980s were the only successful landers to operate briefly on Venus's surface. These missions returned valuable data, but the harsh environment quickly destroyed the landers. New technology and innovative approaches are needed to overcome these challenges, but the scientific rewards could be enormous. Another aspect worth mentioning is the potential lessons Venus could offer about planetary protection and the importance of maintaining a habitable environment. Earth and Venus started out with similar conditions, but their paths diverged drastically. This divergence offers a stark reminder of how delicate the balance of conditions necessary for life is. Venus shows us a planet where things went wrong, a planetary cautionary tale. By studying Venus, we can better understand what factors contribute to planetary habitability and what can cause a planet to become uninhabitable. The story of Venus is far from over. Each new discovery adds another piece to the puzzle of its complex past and helps us understand what might have happened to its lost oceans and potentially habitable environment. As we prepare for future missions, we have the chance to unlock more of Venus's secrets and, in doing so, learn more about the fate of our own planet and others like it. Could understanding Venus help us protect Earth from a similar fate? Or might we find clues that change our search for life elsewhere in the universe? This is why Venus continues to captivate scientists and space enthusiasts alike. It is a reminder of the dynamic and ever-changing nature of planets and the mysteries that await us in the cosmos. As we uncover more about Venus's past, we also look forward to a future where the secrets of our neighboring planet are finally revealed. What are your thoughts on the possibility of Venus having once been habitable? Do you think we might find more evidence that could point to life on Venus in the past? Let us know in the comments below, and don't forget to like and subscribe for more deep dives into the mysteries of the universe.